Hi guys.
Hey.
Hello. Can you hear us?
Yes, I can hear you loud and clear. I'm recording so that we have it for later as well. Everyone can hear me, right?
Yeah.
Okay, we start at the welcome slide. So it's slide 1, right? Okay, then let me just welcome the classroom. I hope everyone can hear me loud and clear. It's very an honor to have you there in the classroom. And I just want to shortly introduce the 3 people which are mainly involved in this workshop. It's of course me, Arno Pfefferling. It is Ayara Yuj-Cruikshank and Peter Stewart, which you will hear in the later time. So since we lost some minutes, let's go to the next slide, please. It is a pleasure to, I cannot see all of the people in the classroom, but it's really nice, and thanks to Eunice, Andre, and everyone who is helping to make this workshop work. We just have some minutes left. I think 40 minutes are left for the basics of blockchain and cryptocurrency. The second part will be in hands-on, where every person in the classroom has to work on the computer in front of him. This will be done by Peter, so this will come as the end of the first day, and tomorrow we have another session where you also can have a lot of Q&As. So let me just start with the presentation, and let's go to the page 3, this decentralization slide. You have it open, Andre?
Yeah, we're good.
Okay, so I hope every one of you can see in the middle there is gray boxes, which is kind of ledger entries. So in a blockchain, what you are doing is you're building a hierarchical transaction tree, which is called Merkle tree, because in every transaction you're building a hash, which I will show later what a hash is. It's a fixed length of encrypted information, and every transaction has a timestamp. That's why we can build kind of a tree. And the special thing why blockchain is immutable is if we change one of these transactions within this tree, the end hash, the end resulting hash will be different. That is why you see here every old block is giving a previous hash. It's the short form here for your prev hash. And this is building a chain of hierarchical transactions. And this is how we can ensure that this chain which was built is immutable and unchangeable because of this hashing, which I will describe in another slide. On every slide, and the whole PDF has YouTube links where you also can have kind of read at home or in your self-studies where some other things are explained. So, okay, we have not much time left. So important for you is to know that Bitcoin is founded in the year 2008. And since then, it evolves more and more. And I will show some parameters of this evolving. But first of all, why we are saying that we have with blockchain a decentralized database. It is because here you can see a picture of the very left. You see the central point, which is the centralized system. Then in the middle, the second from the left is a decentralized system where we have a lot of small central points, and they are somehow connected together. And a 100% decentralized system is actually the third picture. It's a distributed network, which is the third picture from this white box in the middle. And now you will ask maybe, okay, we have more than 1,000 blockchains, and how we can measure the decentralization of them. This is done by the so-called Gini Coefficient, which is described on the right side of this slide 4. I hope, Andre, we are on slide 4. There on the right side, you can see the Gini Coefficient, which describes if some system is 100% decentralized, you have this straight line, which is the line of equality. And if we are, for example, more and more in the centralized system, which is shown in this white box on the left with the central point, then this curve is bowed like a Lorentz curve. We use this Gini coefficient in a lot of other economy factors, for example, to show how the wealth is distributed in a country. And if we use it in the blockchain world, we call it the Nakamoto number, which is somehow a weighting, like it's putting a weight in a distribution, because If you get payment, then it's an easy number, which can be calculated easily over a group. But in blockchain, we have kind of binary functions. That's why we have to build some grouping, and this is the Nakamoto number. Okay, how does it look like for Bitcoin? As I mentioned before, Bitcoin is the oldest cryptocurrency out now with this blockchain database system. And if we look in the mining, which is needed to build this chain, which I shortly described and will describe furthermore, we have a decentralized system in 2017 of 5 of these groups. So the Nakamoto number from 2017 is 5. If you see these red bars, these are more than 50% of the global hash rate. If we look today, 2018 May, then you see that the Nakamoto number is only 3, which means that more than 50% are owned by only 3 big pools. So we can now see in the Nakamoto number that actually a blockchain distributed system is not distributed, it's a centralized system if we look in the subgroup of mining. So this is what I described with the Nakamoto and the Gini coefficient. You can see here the numbers. So let's go to slide 6, please. So I hope every one of you got the idea of the Gini coefficient and the Nakamoto number, because these are important measurements for decentralization. And in blockchain technology, everyone is saying it is distributed ledger and stuff like this. So this is why it's important to understand these numbers. Now, if we look in Bitcoin again, which by the way is the oldest cryptocurrency out there and the biggest and most dominating cryptocurrency, if we check the node distribution, like the Gini coefficient for the distribution of the nodes worldwide, which kind of are servers which share the database, then we see that in 2017, July, we have 3 groups, like Nakamoto number is 3, which are owning more than 50% of all the servers and nodes worldwide. And the problem with this 50% is always, if I own more than 51% of a blockchain or of a cryptocurrency in power-wise, then I can control and say where this database is evolving in. So for proof of work, it is different. For proof of for the node distribution, it's different. And for example, if I own more than 51% of the total amount of a cryptocurrency, like I own most of the coins which are out there, then I can manipulate it. Then I have this centralized controlling power. And if we are staying in the nodes, if we go on the left picture, which shows 2018, we still have only 3 countries, US, Germany, and China, which are owning more than 51% of all the nodes. So this is somehow a controversial situation, because blockchain says it's distributed, decentralized, but in real world and in the real best use case of blockchain technology, which is Bitcoin, you see you actually have a somehow centralized system, even so if the technology is decentralized. So let's go to slide 7, please. Andre, you're on slide 7?
Yes, slide 7.
Great. So besides these numbers which I showed, and besides the basic characteristics of a blockchain, I want to give you a short introduction in the participants, or in the rules or roles actually which we have. So on one hand, you have to have kind of an access to the blockchain, which is the wallets. It's kind of the graphical user interface clients, which is this W, this V. And on the right side, we have, for example, the nodes, which are the servers which I described with the example of the distribution. Then the previous described, we have this consensus, which is the proving mechanism to build the trust. And of course, we have the database, which is the blockchain itself. And for all these 4 roles which we have in this system, we now can go more in detail. So let's go to slide 8, please.
Slide 8.
Yeah, on slide 8, I compared for the consensus algorithms which we have. So for example, in proof of work, the most common ones are the SHA-256 algorithm, which I will show later also. Then we have the second most used one is ETH hash, which is, of course, you might know Ethereum using. And every algorithm has some specifics in using computing power and in using the random access memory. So this is why we have different devices for solving this consensus. And proof of stake, for example, does not need much computing power, but you in proof of stake need to have some kind still the consensus and trust mechanism. So that is, for example, in this delegated proof of stake, the short form DPoS, you use a staking amount of coins to verify transactions. On the other hand, you have also the delegated Byzantinian proof mechanism, short form DBFT, which, for example, is using Tendermint. And I highly can recommend Tendermint, which is an open source framework for blockchain developers, if they want to understand the fundamentals of consensus. Because in Tendermint, you can have different consensus mechanisms, proof of authority, proof of stake, or just the normal Byzantine mechanisms. So please use the follow-up links to go more in detail there. So let's go to the next slide, please, slide 9.
Right, slide 9.
So as I mentioned, every proof of work algorithm has some specifics, for example, in computing power or memory usage. And for this, we have different devices to solve this consensus. So in the bottom, I showed the classical state-of-the-art devices. In the middle, you have the most sold ones. It's Antminer. The small one in the middle is the Z9, recently released. On the left side, you have Dragonmint ASICs. They look almost the same, but this one is for Bitcoin, for example. So besides that, the interesting thing is we also can do the proof of work for blockchain, for cryptocurrencies with hard disk space, which is shown in the top right. There is this black boxes. These are hard drives. It's like roughly 120 terabyte of hard disk space. And the coins which you can mine, for example, are burst, or you can get tokens, which are called storage, for distributing your disk space. Then on the other side, we have, of course, the graphic card mining, which is shown on the bottom right. There's just some mining rig. And for this, you mostly mine Ethereum, for example. So then we have also only CPU mining, which is shown here as Varium, or Nexus is also a coin which is mostly efficient to mine with the CPUs. Okay, please on slide 10.
Right, slide 10.
So as I mentioned, we have 4 core roles in the blockchain or in cryptocurrencies. And one of these was the wallet, like the graphical user interface, the client to access actually the data, to access through your private key to the blockchain. And I just put some here because it depends on what you want to. It depends what operating system you have. It depends if you want to have the full database on your hard disk, which needs a lot of space. This is why we say we have light and full clients. Or, for example, you need a specific wallet where you want to encrypt the database, or you just want to have multi-coins or a single coin. And these ones which are shown here, these are good examples. So, for example, if you want to use a wallet with several coins, several cryptocurrencies, you can use Jax, Exodus, or Koinomi. If you want to have a good old Bitcoin-only wallet, you can Electrum. And most important for you is we can also have some hardware wallets where the private key is stored in this hardware device. So if, for example, you lose your private key, you can have this device where it's stored and you have some recovery passphrase. So it's still not 100% safe, but it's safer than just paper wallets which can be burned or which can be lost. I mean, these devices can also get lost, but it's this kind of second level for storing your private key. Okay, next slide, please.
Right, slide 11.
Yes. So this is, I think, the most technical slide because it is somehow explaining how the Bitcoin algorithm for consensus is working. So as I mentioned, we have proof of work, and actually what all these machines have to do is they have to use these Merkle trees and they have to calculate on the based transactions which are given within these 10 minutes to this short number. And if you look in the middle, there's the white box where we have some old SHA. It's the 224 SHA. Bitcoin is using a higher SHA, but for an example, it's good to use. There you see that the word which is encrypted is totally different in the hash code. Hash code starts with the 0x, and both hash codes are totally different, but I only changed in the lower sentence the dot after dog. So in this is valid for every sentence or for every passphrase which I'm encrypting through the SHA algorithm. So if I change one byte, all other bytes from the hash are changed, and this is why if I build now a Merkle tree with it, if I change one old transaction which is in this tree or in this hierarchical database, then I never can reach the same again. And this is ensuring that I can build the trust and that I can legitimate the hash which is built. So this is kind of the basic understanding. If you want to look more in the hashing algorithms, please just check the Wikipedia out because it is a very basic NSA-funded algorithm. The picture on the right is somehow describing the mathematical operations, which are of course complex. That's why I only can show you some rough overview about it. Please, the next slide.
Slide 12.
Okay, so we have 15 minutes left until to the tea break. So I just will show you a roughly overview about the market and about the cryptocurrencies, which are the first big use case of blockchain, of course. Blockchain can have several other use cases, but to have a cryptocurrency is the most common and the most effective right now. So you will wonder that Bitcoin, for example, has a value that one Bitcoin is above, for example, 6,000 US dollar or above 7,000 US dollar. But you know, it depends, which I wrote here is, for example, how many users are using it, how much is the circulating supply. For example, in ZenCash, we have a circulating supply roughly about 2 million US dollar right now. So every 24 hours, 2 million of value are exchanging between one person and another, or between entities like industry entities or something. And of course, so this means not only number of users are describing it, also number of merchants or applications are describing how much value is in your cryptocurrency. And just to give you an example that, for example, Doge, which is a fork of Bitcoin, is also has a very unique selling point because it's very old. So this also can be a point of increasing value. If I'm the first one on the market, then of course, if I'm stable and I'm still working, which for example Bitcoin is, then the value increases over time, which is also a very important point to see. So next slide, please.
Slide 13.
No, 13, please. 13.
Yes, 13. Yeah.
Okay, here I just roughly show the possibilities of now gaining a cryptocurrency. You normally get cryptocurrencies on exchanges or persons which you know, but the most common places are exchanges, and there you have several rules. Some are anonymity. For example, if we go to the left side, you have Evercoin, BitMEX. These are like kind of instant working exchanges where you have this KYC means know your customer, so you can be anonymous, or at least you can use pseudonymous emails. Then I thought what is important for you guys is also if you have credit cards, Visa or MasterCards, then on the right side you have Indacoin and Changelly, where you can easily access a lot of cryptocurrencies. Then I thought if someone of you have cryptocurrencies and wants to transfer fiat is by the way Kenyan shillings or euro, then these two in the middle are okay. In Exmo, CoinMama, you have Western Union plugins. If you want to have bank transfers, which are wire transfers, you can just use the most big ones like Bittrex, Bitfinex, or HitBTC, for example. I don't advertise any of these exchanges, but these are the common ones, and in the group they are the ones which are okay to use. Important to understand is, if you are using an exchange, the exchange owns your private key. So you are not 100% under control of your cryptocurrencies. That is why it is somehow risky, because you're giving away your 100%, you're giving away the control of your coins, of your money. Okay, next slide, please.
Right, slide 14.
Yeah. So I think I'm almost done. So the next slides are somehow reviewing and giving you also the understanding of if you're questioning yourself, okay, do I have to buy or how do I get in the market? Then there are several ways. So what I recommend every one of you, especially the younger ones, which are limited in resources, start trying to get the programming, start to be a developer, join some cryptocurrency projects and see where you can bring in your personality. For example, some are just good in doing blogs and writing or translation, then they can join some projects and just do the translation and earn this way the cryptocurrency. Just to have a short story here, for example, Vitalik Buterin, which is the co-founder of Ethereum, he started in writing blog articles about Bitcoin. So he was earning his first Bitcoins just in putting some articles about Bitcoin out there. So this is the way where you also can participate. And even so, maybe it's more profit, it's giving you more profit than the other ways. Because mining in cryptocurrencies is possible, but you have to also do your research and you need a lot of capital. And of course, there's still risk. So I think the less risk is in just participating. Even if you're a developer, it's most easy for you. Just look for a project, go on GitHub and distribute your knowledge. And a third way, which is important, is this node thing, where you are be part of the infrastructure of a blockchain, where you are part in this way in a cryptocurrency. And this is what you will learn in the second part today and tomorrow also, because we have divided the hands-on in two parts. So this is also a very important way to earn cryptocurrencies and to start in adapting it and then start in using it. Okay, next slide, please.
Right, slide 15.
Yes. So right now, up to now, I was not talking much about ZenCash, but now it's a little bit time for it because ZenCash is a privacy coin, and actually it is important to understand that in blockchain, every data, if you are using a public chain, then everyone can access this, because this is the point in it. I have a idealistically distributed database system which everyone can access and which everyone can read. At least if he has a private key, he can only access his wallet address, for example, but generally you see the amount of coins which other addresses own, for example. And in ZenCash there's a way to have an intransparent transaction, and in this way you have also intransparent addresses where you can store your amount, your coins, in a way that no one else can see it. So I think it's clear that this gives you the opportunity to hide, of course, to hide personal information, because I don't want to show everyone how poor or rich I am. And then, of course, if you are paying for some service with a cryptocurrency, you also don't want to give the information to other people how much you paid for some service. So this is possible, and this is under the hood of privacy. I please encourage you to also check here the follow-up link and read and think about what privacy matters to you, because it's a human right and you should not throw it away, especially if you are new in the blockchain technology. Remember that it is an immutable ledger, it's an immutable database where your actions are tracked forever and you cannot remove it. So please think twice what you are doing on blockchain. Okay, then I think the next slide, please.
Right, slide 16.
Yeah, this is just to give you a brief. So what I mentioned, what is centralization? I mentioned, okay, what is a wallet? We talked about the core 4 roles in blockchain. Tomorrow we have more Q&A, so just write down your questions, and if the internet is good, I hope we can have a nice discussion. I stole enough time. I think it's now time for the hands-on, and yeah, so then the next slide, I just will prepare a little explanation about the nodes. So next slide, please.
Right, slide 17.
Yes. So okay, what are secure nodes? Just shortly, we noticed in ZenCash that if we give the node operators, the ones who are distributing their servers, their computers in the infrastructure network, that we thought, okay, we have to give them a reward. This actually is not so new. There are some other cryptocurrencies which have this incentive, but in ZenCash we are giving this block reward if you are already have only staked 42 cent. So it's 42 cent is right now I think roughly about 1,500 US dollar, which is still expensive. But this is like a good investment, to say so, because you're not losing it. You are the owner of the coins, so you always have the control over the coins. And in this way, I cannot say that you buy something from us, for example. No, you buy a cryptocurrency and then you can put it aside, and it is growing on its own. So this is where I actually see the block reward. And if you have costs for running or renting a server, then you can use this block reward to pay for these costs. So it's somehow an incentive for you to think about, okay, if I am distributing, I will at least get some cost reduction, for example. Okay, so I think then we are ready for the hands-on. And Andre, I don't know if you want to have a tea break or if Peter just takes over.